Hello learner, welcome to Manifested online classes. My name is James Kenyani. We are yet again going to proceed with our longitudes and latitudes, and today we are still looking at further solutions with the objective of enhancing more skills in the learner. So the lesson further solutions, objective to enhance skills of solving questions on longitudes and latitudes in the learner. So straight to an example that gives us a wider experience. So I'm going to jot down an example. Example K. So learner, the first and very important thing you have to do, is going through the question. So in the question, an aircraft is 3,600 nautical miles north of the equator and 60 nautical miles east of town P, which is on the same latitude as the aircraft, but has a longitude of 5 degrees. Calculate the latitude and the longitude of the aircraft. So in the solution, as I earlier said, a diagram is very important. You have to sketch a very good diagram so that you know how you are moving. So the first thing to locate is always the equator. So you have your equator. From the question, there is some relationship. There is a town P. It is on a longitude of 5 degrees. 5 degrees. So you can try locate that. Given that this is the Greenwich Prime Meridian, the aircraft is on a certain latitude which you don't know. So this is the point of the town P. There is a town there P. And given if that is the center of the earth, this is 5. So sorry for that, it is west. So we shall relocate these. It is 5 west. So we relocate these. That is town P. So a diagram is very important because it will help you. So it is given its longitude is 5 degrees. But it is on a small circle. It is on a small circle. So there are two questions there. One, calculate the latitude and the longitude of the aircraft. Latitude and longitude. But they have given you this distance. So you write the distance from the equator the distance from the equator to the aircraft. So you'll come here east of town fee. So the aircraft is somewhere here. Aircraft. So they are looking for that distance. That distance. That distance is given. That distance is given as 3,600 nautical miles. So the distance from the equator to the aircraft is distance on a great circle. It's distance on a great circle, and we learned that 1 degree subtends 16 nautical miles. Subtends 60 nautical miles. So this difference in, if you look at that difference theta, I can call that theta. Difference in latitude, latitude between the equator and the aircraft, times 60 nautical miles is equal to 3,600 nautical miles. So I can call this one theta. Theta. So it is actually this angle, theta degree. So I can say theta times 60 nautical miles is equal to 3,600. Therefore, theta is 3,600 divided by 60. That gives 60 degrees. So the latitude of the aircraft, the latitude of the aircraft is 60 degrees. 60 degrees, in fact, north of the equator. It is 60 degrees north of the equator. So it came from a difference in latitude. This one, since it is on a great circle, multiplied by 60 nautical miles, because 1 degree subtends 60 nautical miles. It will give you the distance they have given you as 3,600 nautical miles. That's why we came and get theta, which is now the latitude of the aircraft. Let's move again. Where do we use this 60? 60 is the difference. Now you'll come for B, extract that small circle. Small circle. We have that small circle. It is in fact here. That small circle. So that is the best representation. So here you realize the difference. This is a small circle. Of latitude 60 degrees north. So the distance, that distance, say the distance from P to the aircraft is distance on a small circle. On a small circle. It is distance on a small circle. So given this 60, you'll say change in longitude you'll say x degrees times 60 nautical miles times cos 60 degrees. Where do we get 60 degrees? It is on latitude 60 degrees. That's why you multiply by the cosine, because its radius is actually smaller than the radius you'll have at the equator. This will give you 60 nautical miles. That was given in the question. 60 nautical miles. So not whether it is on a small circle. You realize since it was on a small circle, we are multiplying by the cosine of the latitude. You'll find the distance on latitudes, you'll be multiplying by the cosine of that latitude. But if it was a longitude, it is a small circle. I just multiply direct. So I'll come here, x degrees times 60 times cos 60 should give me 60. So x is equal to 60 times 60 divided by 60 times cosine 60. Cosine 60 is 0.5, so it is 60 over 60 times a half, which is 60 over 30, which is 2 degrees. So the longitude difference between the aircraft and P is 2 degrees. Is 2 degrees. Therefore, longitude of P of aircraft will be 5 degrees west, subtract 2 degrees, because the aircraft is easterly. You should understand that the aircraft is easterly. So if I have here the Greenwich Prime Meridian, if I have here P, this is more to the west, that is more to the east. So if P is here, the aircraft is here, you move to the east. So the difference there you find is 2 degrees. So actually you'll move to the west. You move towards 0. And this gives you 3 degrees west. So you go back to the question, calculate longitude and latitude of the aircraft. They are actually asking for the position of the aircraft. So the aircraft is, we come to the latitude 60 degrees north, stroke 3 degrees west. That gives you the longitude and the latitude. They are actually asking for the position of the aircraft. So check. Always a diagram comes in handy to help you to scale down and understand what is happening. Distances along great circles. The distance from the equator to the aircraft is a distance on a great circle because it is on a longitude. It is on a longitude. When you come to a small circle, something comes in. The cosine of the latitude comes in. That's why we have, it is now the longitude difference. The longitude difference, x times 60 nautical miles times cos 60. You'll get that distance given. From there, you'll get the value of x, which gives you the longitude difference. When you come to the getting the longitude, since the aircraft is more easterly from the question, east of P, you subtract the 2 degrees. So with that, you'll get some assignment. So that is the question. I'll just demonstrate using the globe. I'll demonstrate using the class globe. So the question goes, two planes are on the same parallel, 60 degrees north. So Lana, 60 degrees north. 60 degrees north is somewhere here. I'm not saying exactly there, but it is there. So they are here. One of the planes is here. And their longitudes differ by 180, which means another one is exactly directly opposite, a half turn. If you make a half turn, 180 degrees, you'll get the other one. That correct? Yes, they lie on the same latitude, but their longitude difference is 180 degrees. It means if you make a half turn, you'll get the other one. The other one is directly a half turn, but on the same latitude. So calculate in nautical miles and in kilometers, distance between the places along a circle via the North Pole. You listen here very careful. So if it is a circle via the North Pole, and it is here, you'll actually move through the North Pole. You'll move through the North Pole. And reason that here you are at 60 degrees. To get, this is the maximum North Pole. At the North Pole, it is 90 degrees. So when you move up to there, the difference is 30 degrees. To move from 90 again to 60, to be directly opposite this place, you'll move through 30. So that will help you to get the latitude difference. The difference in latitude along the great circle via the North Pole. Another one is along the parallel of latitude. So you'll move this way. In B, they are talking of that. In A, you move through the North Pole. So you realize when you are moving through the North Pole, you are moving through a great circle. A great circle. When you move along a great circle, you only take the difference in, especially in the longitude, you take the difference in latitude and you multiply by either 60 nautical miles. And since I had given the relationship between a nautical mile and a kilometer, it is very easy. So it's now very easy to calculate having that information as demonstrated by the classroom globe. So you'll work out that assignment as you continue to sharpen your tips on answering those questions. So thank you very much for your audience, and let's meet in the next lesson with the greatest agility to learn. Bye-bye.